When we use scatter plots, we tend to also talk about correlations. Let me draw a quick sketch here of a graph. Let's say we've got an x and a y axis here. I'm just going to graph a bunch of points and kind of scatter them around, hence the name scatter plot. And then after we get these lines drawn, we can draw what's called a trend line or a line of best fit. When we draw a line of best fit, we want to try to go through some of the points and try to keep about the same number of points above the line as below the line. So it might look something like this. And if you look at this line, it does have positive slope because it increases from left to right. So we would say that this has a positive correlation. And what that means is as one thing increases, so does the other. So an example might be something like the more gas that I have in my car, the further or the more miles I can travel. Alright, let's look at another graph here. This one here in green. I'm going to get some points here and get them scattered around. If we look at that, we can also draw a trend line or a line of best fit. We want to draw a line that can go through some of the points and keeping about the same number of points above the line as below the line. As we look at the line, it does decrease from left to right, has negative slope, so we would say that this has a negative correlation. And what that means is as one thing increases, the other decreases. An example of that might be, say, the more time one spends stretching, the less injuries they will get. So the more time one spends stretching, the less injuries they will get. As one thing increases, the other decreases. Let's say we have a situation where we don't have negative or positive correlation. We might have points that are scattered around like this looks like in the graph here. As you look at that, you can't really see a trend. So we would say that this one has no correlation. Alright, here is a problem about geology. The table shows a duration of several eruptions of the Geyser Old Faithful and the interval between eruptions. We're asked to make a scatter plot for the data, describe the correlation, and write an equation that models the interval as a function of an eruption's duration. So I'm going to start by drawing the x and y axis. Going to label the x-axis the duration, and that's in minutes. Going to label the y-axis, and that's the intervals, which is also in minutes. Going to set up the intervals on the x-axis. It goes from 1.5 minutes to 5 minutes. So we got 1, 2, 3, 4, 5, and so on. The y-axis goes from 50 minutes to 95 minutes. We don't have anything between 0 and 50 minutes, so I'm going to put a break in here and start at 50 and then go up by 10. So this would be 60, 70, 80, 90, and 100. Next, I'm going to graph these points. So 1.5 and 50 is there. 2 and 57. 2.5 and 65. 3 and 71. 3.5 and 76. 4 and 82. 4.5 and 85. Oh, 4.5 and 89. 5 and 95. Next, I'm going to draw a line of best fit that goes through some of the points and also keeping about some of the points above the same amount of points above the line and below the line. So got a line going like that. And okay, now I'm going to look for 2 points that the line of best fit goes through. So I'm looking at this point and this point, which in the chart we have this point and this point. As you write them as ordered pairs, we have 3.576 and we have 4.0 and 82. So this then becomes the x1 and the y1. This becomes the x2 and the y2. So I can find the slope by using the slope formula. And if you recall, the slope formula is y2 minus y1 over x2 minus x1. And we plug these in, we get 82 minus 76 over 4 minus 3.5, which then gives us 6 over a half. That gives us 12, so we know our slope is 12. Now if we were able to extend the green line out and see where it hit the y-intercept, we could find the b. But we can't do that because the way that I did the break, so I'm just going to use the equation y equals mx plus b so I can find the b. I'm going to plug 12 in for the slope, and I'm going to use this point here, so I'm going to put 4 in for x, and I'm going to put the 82 in for the y, and now I'm going to solve this for b. 12 times 4 is 48. And if we subtract 48 from both sides, we find out that b equals 32. So my equation, if we're using y equals mx plus b, I'm going to plug 12 in for the slope, and I will plug 34 in for the y-intercept. And it asks to give a correlation. Since it has positive slope, we have a positive correlation, which means as the duration increases, so does the interval.